All right, so if you're building an AI agent, you've got a design doc, right? It's got the model, the orchestration layer, all that good stuff. But I'm willing to bet it's missing something absolutely critical. And that missing piece, it's probably costing you a ton of money in both performance and your budget.
So let me ask you this. What's the most expensive, unowned piece of code in your entire AI stack? The one thing that's massively impacting your costs and your results, but nobody's name is on it? The answer is probably something you haven't even thought to name.
And that right there, that gets us to the heart of it. Because what we're talking about isn't really a technical gap. Nope, it is an ownership problem.
Okay, this whole process probably looks super familiar, right? A dev writes a prompt, they tweak it a couple of times, it kind of works, and then it's just forgotten. It's ship it and forget it. But then, when performance tanks or you start getting these bizarre results, suddenly nobody knows why. It's become this black box right in the middle of your own system.
Well, that missing piece actually has a name. It's called the harness. And no, it's not some new framework you have to buy or another layer in your stack. It's the actual code, the nuts and bolts, that decides everything your model sees at every single step. We're talking about what goes into the prompt, what gets retrieved, what's kept in memory, and what gets tossed out.
Okay, so this is where it gets really wild. Researchers found that if you take the exact same model, but you just change the harness, you can get a, wait for it, 6-fold performance difference. I mean 6x! That's not a small tweak, that's a massive, game-changing improvement.
And that brings us to the single most important point here. If you're getting a 6x performance swing just from the code around the model, well, then your biggest bottleneck isn't the model. It's not the LLM. It's an ownership problem.
So what's the real cost of having no ownership here? Let's break down the tangible impact on your bottom line.
This visual really lays it all out. The harness, it's stuck in this gray zone, this no man's land. It's right between the ML engineers who are focused on the intelligence core and the platform engineers who are managing the infrastructure. It's this absolutely critical piece of the puzzle that nobody officially owns, and that's exactly where the problems start.
So what does the harness actually control? 4 big things: prompt construction, retrieval policy, stuff engineers often decide once and then never look at again. But check out the last 2. Memory management, that's your biggest context cost right there. That's your cloud bill spiraling. And state update logic, that's the biggest source of your production failures. So this little piece of unowned code is directly hammering your budget and your product's reliability. It's a double whammy.
Okay, so we've established the problem. It's handwritten code that barely gets iterated on. The solution, then, has to be a system that can optimize it for us, automatically and at a huge scale. Let's dive into how that actually works.
So the researchers behind this had a really key insight. Most of the optimizers out there, they're fine at telling you that something failed. They spit out a score. But in the process, they compress all the feedback and they throw away the most important signal you could possibly have: why it failed. MetaHarness is totally different. It does not compress. It keeps everything.
And the process is it's so simple and elegant. You have an AI coding agent that proposes a version of the harness. That version gets evaluated. And then everything, we're talking the source code, the scores, the full execution traces, it all gets logged. The AI agent then reads all of that raw data before it proposes the next iteration. It's just a simple, powerful loop. Propose, evaluate, log, and repeat.
And the scale here is just mind-blowing. A single one of these evaluation runs can generate up to 10 million tokens of diagnostic info for the agent to learn from. And because none of it is compressed, the AI can trace a failure all the way back to its root cause in the code and suggest a super targeted fix. That is a level of deep iterative analysis that a human engineer just could never do by hand.
So what are the results? What do you get from all this systematic, large-scale optimization? Well, honestly, they're pretty incredible. We're not talking about a small improvement here. It's better, it's cheaper, and it's all automated.
This graph right here tells the entire story in one picture. On the bottom, you've got cost, how many context tokens you're burning. And on the side, you've got performance, accuracy. See, all the old ways forced you to make a trade-off between the two. But look at MetaHarness. It just leaps to a completely new spot on the chart, way higher accuracy for way, way lower cost.
Let's break down the actual numbers. Look at the prior state-of-the-art, a system called ACE. It got to about 41% accuracy, but it had to burn through over 50,000 context characters to do it. Now look at MetaHarness. Remember, this isn't handwritten. It hits almost 49% accuracy. That's a huge 8-point jump.
And it does it using 4 times less context. Just over 11,000 characters. Incredible.
And this is the key takeaway, especially for any manager or leader watching. This isn't a trade-off. You're not stuck choosing between better quality and lower cost. This is just a fundamentally better operating point. It's that simple. You get better results for less money. Period.
And when you're operating at scale, that efficiency gap isn't just some number on your cloud bill. It translates directly into real business value. We're talking lower latency for your users, higher throughput for your whole system, and a much bigger margin for reliability. Basically, it makes your entire AI application faster, more scalable, and a whole lot more robust.
All right, we've laid out the problem, the cost, and this really powerful new solution. So the big question is, what can you do about this like today? Here are 3 concrete actions for your team.
First thing, audit your ownership. Seriously, go ask your team, who owns the harness? If the answer is nobody, or even worse, everyone, that is the absolute first thing you have to fix. Second, measure what matters. Shift your main cost metric away from just model pricing and onto context efficiency. That's where the real money is being spent. And third, search. Don't just patch. Stop trying to fix your one-off, handwritten harness forever. Instead, treat it like a search problem. Deliberately test different versions and log everything.
So I'll leave you with this question to take back to your team. Who owns the harness? Because if you can't point to one person or one role, I guarantee that gap is already costing you. It's showing up in your cloud bill and in your product's reliability right now.
For way too long, this absolutely critical piece of code has just been handwritten, barely touched, and treated like an afterthought. Well, now we know. There is a better way. A systematic, automated way to get it right.